Hey everybody! This video will go over the topic using a given zero to write a polynomial as a product of linear factors given that it has complex zeros. So this is very similar to one that is talked about in the previous section, and I have a video on that, using a given zero to write a polynomial as a product of linear factors, when we're just talking about real zeros. But right now we have a possibility of getting complex zeros. So how is this different? Well, I know that 2 is a 0. So that means if I do synthetic division on this, I should get 0 as a remainder, thanks to the remainder theorem. So bring down the 1. 1 times 2 is 2. Negative 4 plus 2 is negative 2. Negative 2 times 2 is negative 4. 30 plus negative 4 is 26. 26 times 2 is 52, and I do get 0 as my remainder. Okay, so that tells me, that f of x equals my x minus my 0 times the quotient that I got, which is x squared minus 2x plus 26. Alright, now I can try and factor what I have left, but it won't factor. So do the negative b plus or minus square root, because I have to let 0 equal this x squared minus 2x plus 26. And the only way to solve this is with the quadratic formula. So x equals 2 plus or minus the square root of negative 2 squared minus 4 times a, which is 1, and c, which is 26, all over 2a, which is 1. Now after solving this, or simplifying a little more, we're going to get square root of negative 100 over 2. So x ends up being equal to 2 plus or minus 10i over 2, which is equal to 1 plus or minus 5i. So how do we express so 2 and 1 plus 5i and 1 minus 5i are our zeros. So our function as a product of linear factors is going to be x minus 2 times x minus one of our other zeros, which is 1 plus 5i, and then x minus our other 0, which is 1 minus 5i. And right there we already have it. We have the product of linear factors. So that one is very similar to the other one that I did previously. But now we have imaginary or complex zeros.